Hello everyone, welcome to this new video. So as I've told you in one of my previous video that I had left one problem, right? At that time I did not cover the concept of this SWR, standing wave ratio. So in the previous video I had covered the concept and we have got to one formula for standing wave ratio, that is in terms of rho it is given by 1 plus magnitude of gamma divided by 1 minus magnitude of gamma, right? So this is the formula which we have derived in the previous video, and we have seen the relation between the reflection and transmission coefficient under both standing waves and standing wave ratio. Okay, so those who have not seen that video, please go and watch it. It is just available just previous to this video. In this video I am just going to complete this problem and get to the new concept, that is with respect to Smith chart. Okay, so what do you mean by Smith chart, what it consists of, how the plot looks like, and what are its characteristics, everything I am going to cover in this video. Okay, so the problems related to Smith chart, I guess this time I guess they won't be asking the problems, but what do you mean by Smith chart, its characteristics and the construction of Smith chart, everything I guess they might be asking that. Okay, so that I'm going to show it in this video in the notes which I've already this is the notes here. In this notes I've already written it. So this notes I've already circulated it in the video's description. Go and access it. So yeah, let us see this problem. So in this problem, just substitute the values of this gamma which we have got here in this case. Okay, that is 1 plus 0.364 angle minus 80.53 degree divided by 1 minus 0.364 angle minus 80.53 degree. Okay, so now what to do, just add this. So this would be 1.364 divided by, it would be around 0.636. okay, and angles, that is minus 80.53 degree and minus 80.53 degree. In both in these two sums, numerator and denominator, the angles are same, it would be cancelling each other, and finally divide these two terms and get the standing wave ratio. In this case I have already calculated it, the answer is 2.21. okay, so this is the standing wave ratio. Okay, as I have told you, standing wave ratio would be strictly greater than 1 because it is in the numerator we have 1 plus gamma divided by 1 minus gamma, right? Whereas in case of reflection coefficient it is ZL minus Z0 divided by ZL plus Z0. Okay, that is this term ZL minus Z0. So that's why, since it is a negative, it is subtracting in the numerator, so that's why the answer would be strictly less than 1. Whereas for standing wave ratio it is greater than 1. Okay, always the value. So this is the answer here for this problem. So note it down. Now let us get to the actual concept of this video. So this is the actual concept of Smith chart. So what do you mean by Smith chart? This is a graphic method to solve the transmission line problem. So okay, so whatever the transmission line problems we have seen till now in our previous video with respect to reflection coefficient, transmission coefficient, standing wave ratios, and with respect to the parameters of characteristic load impedance and all, everything was done in problems, right? So this Smith chart is a graphical method. Okay, it consists of normalized impedance or admittance. So now consider the reflection coefficient. In this case let us consider it as gamma 1, that is given by ZL minus Z0 divided by ZL plus Z0, that is equal to gamma L. It can be also be written as e to the power j theta L. Okay, where gamma L is less than or equal to 1. Now gamma L must lie on or within the unity circle. Why? Because we have already told you the condition of gamma, when it is unity there is no reflection happening. So that's why whenever it is unity, since there is no reflection, so that's why always the gamma L with respect to the Smith chart should be lying in the unity circle. Why? Because that during the construction of Smith chart I am going to tell you why. Okay, so that's the thing. And one more thing, reflection coefficient along a line is given by gamma D. Okay, along the line it is given by magnitude of gamma D, that is equal to gamma 1. In this case it is this term, e to the power minus 2 2 alpha d into e to the power minus j 2 beta d. Okay, 2 times. So that is equal to gamma L into e to the power minus 2 alpha d into e to the power j theta L minus 2 beta d. Okay. So this is the reflection coefficient along the line under Smith chart. So this expression you please note it down. Now normalized impedance along the line is given by Z is equal to Z by Z naught. That is Z is equal to 1 plus gamma L e to the power minus 2, and this is the propagation constant gamma d divided by 1 minus gamma L into e to the power minus 2 gamma d. With no loss, it is assumed that d is equal to 0. Then this Z is given by, these two terms would be cancelling each other because d is equal to 0 in this case. So e to the power 0 would be equal to 1. So these two terms cancels out. So we are left with Z is equal to 1 plus gamma L divided by 1 minus gamma L, where 1 plus gamma L is called as ZL and 1 minus gamma L is called as Z0. Okay, that is equal to RL plus JXL in terms of impedance and admittance. It is written as like this. Impedance and reactance, that is RL plus JXL divided by Z0, or that can also be written as, since it is getting divided by the characteristic impedance, so that we can be writing it as directly R0 plus JX0. Okay, where Z is equal to R0 have replaced it by small letter r and X0 have replaced it by small letter x. So Z is equal to R plus JX. So name this as equation 1. Also gamma L with respect to Z, what we are getting is Z minus 1 divided by Z plus 1. That is equal to gamma R plus J gamma I. Okay. So for instance, name this as equation 2. Okay. So on solving equation 1 and 2, using these two equations, you would be getting one expression for R that is equal to this term. Okay. So solving part is not required because it is a lengthy procedure. So that's why when you solve these two equations, you should be remembering this, that one R value you would be getting, that is equal to R equal to 1 minus gamma R square minus gamma I square divided by 1 minus gamma R the whole square plus gamma I square. Okay, name this as equation A. And if you solve for X using equation 1 and 2, you would be getting this term here. Okay, once you solve for R and another time you solve for X. Okay, if you solve for X, what we get? 2 times gamma I divided by 1 minus gamma R the whole square plus gamma I the whole square. Okay, so while we solve for X, consider only the real terms, not the imaginary terms. Okay, if you have any imaginary terms, neglect it and solve for the rest of the terms. So name these as equation A and B. Now equation A and equation B can be rearranged and be written in this form. That is, gamma 1 is gamma R minus R divided by 1 plus R the whole square plus gamma I square, that is equal to 1 by 1 plus R the whole square. And one more form that is gamma R minus 1 the whole square plus gamma I minus 1 divided by X the whole square, that is equal to 1 by X the whole square. Okay, so name these two as equation 3 and 4. Now if you compare and see these two equations, you could be getting some note, that is equation 3 represents the family of R circles which has constant radius, that is in this case it is 1 by 1 plus R, and the center, that is R by 1 plus R. Okay, in this case this is of the form the circle equation, that is x square plus y square is equal to a square, right? So in this case a square, a is the radius, so that's why the radius in this case for circle family, in this case it is radius is given by 1 divided by 1 plus R the whole square, and the center point is given by this term, that is R divided by 1 plus R. Okay, in the second case equation 4 represents the family of constant x circles. First it constant R circles, second constant x circles with radius 1 divided by x and center 1. Okay, so this is the radius here and center is 1. Okay, so these are the two equations. Compare it and we compare it with the equation of circle and get the parameters radius and center and write it like this. Okay, so now construction part. Constant for construction part of Smith chart, we have two graphs. One is with respect to R circles and another one is with respect to X circles. Okay, the Smith chart is a combination of these two plots. Actually it would be in one sheet only, it would be looking something like this. Okay, that is from this point it is written like this here. So just imagine these two are placed in a same plot, then like that the Smith chart is actually represented. Okay, so this is in the oval structure, actually it is not like during drawing I had made mistake. It is actually circles, okay? Family of circles here. This is not oval, it is circle, okay? For different values of radius and for different complex values and for different values of radius, it is given like this, okay? Circles of R, where this tends to infinity, and this is RL, okay? RL stands for different radius values for positive instance, and for negative instance it is minus RL, okay? In this case we don't have any negative values, so that's why we are considering only the positive family of R circles, okay? So you see here for R equal to 2, 1, 0.5, 0.4 and 0, how it is constructed with respect to the points mentioned here, okay? And this is for R circles, and this is for constant X circles, okay? For X circles it is called as reactance, and for R circle it is called as resistance. Keep that in mind. And for constant X circles it is given by like this. It is in the form of 1 by X, and this is the plot it is mentioned for Jx and minus Jx for positive complex values and negative complex values, okay? So this is the construction part, how the Smith chart is constructed. Just note it down, and the combination of these two plots is the final Smith chart plot, okay? So you could be searching the images in the Google for Smith chart. You would be they would be giving you a beautiful image where the plot is the combination of these two, okay? So if you observe carefully, it is actually something like this. So I'll draw it here. It would be somehow looking like this, okay? In the image, if you search in Google, it would be something looking like this, okay? Yeah, so this is the construction of Smith chart, which consists of constant R circles and constant X circles in the family of circles with respect to different R and X value, that is resistance and reactance value. And with respect to the equations, we have seen what do you mean by R and X on solving with respect to the normalized impedance and the reflection coefficient, okay? So we have seen these equations, and with respect to that we have constructed this Smith chart. So please note it down, guys, very important. So these notes I have already put it in the description, note it down. So now let us see with the characteristics of Smith chart. So I know that I am becoming a bit fast, but what to do, we need to be completing the syllabus, right? So that's why I cannot be explaining in depth. So how much ever it is required for you guys, that's much I am explaining, and this notes is already available, okay? So if you write this much easily, you will be scoring marks. So yeah, now let us see some characteristics of Smith chart. So some characteristics are, first is the constant R and constant X loci form two families of orthogonal circles, as I mentioned here. So these are the two families. One is constant R circles, that is for resistance, and constant X circles for reactance. So the constant R and constant X circles all pass through the point of gamma R equal to 1 and gamma A equal to 0, okay? The upper half of the diagram represents plus Jx, as I've told you, the upper half for positive complex values and lower half for minus Jx, okay? For admittance, the constant R circles become constant G circles, that is the conductance circles in case of admittance, and constant X circles become constant B circles in case of susceptance, okay? So distance around Smith chart once is half of the wavelength, okay? So distance around the Smith chart once, okay? If you want to see the complete Smith chart distance from one point to other point, it is from one point to other point, the full distance is lambda. If you want to distance around the Smith chart across one wave once from one point to other point, to not reaching at the same point, from here to here it is lambda by 2, okay? For full circle it is lambda, for half circle it is lambda by 2. At a point z min equal to 1 by rho, there is V min on the time z max equal to rho, and there is V max on the time z min equal to rho, okay? So this is the circuit for that. So this is not required. So these few characteristics are very, very important in order to understand in brief about Smith chart, okay? So this was the diagram that I was talking about, the complete Smith chart diagram. That is a combination of both R circle family and X circle family, okay? So this is the diagram, how the Smith chart actually looks like when the two diagrams are combined. So please note it down, okay? So that's all for the video, guys, and that's all for this module also. So with this video, the module 1 has been completed. The notes has already been circulated. Go through it, guys. Very important. Some of the concepts I've covered only the important ones, important concepts only. And I know that some problems are pending to be solved. I know that there are a lot of problems to be solved. I've solved only around 2 to 3 problems. So that's not sufficient. But if time permits, after all the modules, I would be separately solving problems from all the modules. Okay. So stay tuned for that also. I would be definitely solving that. I promise you I will be definitely solving that, okay? By analyzing the previous year papers and all. For each module, different set of problems I'm going to solve it, okay? Because the problems they would be asking for the exam along with the theory. So this subject is very tricky. Very limited resources are available in internet and limited videos are also available. From my side, I will be trying my level best to provide best content with respect to the VTU syllabus and important stuffs, okay, all the important stuff, so that you would be passing the exam. So with respect to keeping that intention in mind, I'm doing these videos. So your job is to watch my videos, all the videos whichever I cover in this subject, and try to understand the concepts. Read my notes which I've already given in the description. Read that. It is the handwritten notes written by myself by copying my lecturer's notes, okay? Whatever they do in the class, I copy that, and that notes I'm circulating it to you guys, okay? With as much as possible, I've written these notes neatly so that you would be copying it, and all the important concepts only I'm trying to cover it and circulating it to you guys, okay? So your job is to study and score good. So with this, module 1 is completed. And from the next video onwards, I'm going to start with module 2, that is based on microwave networks, okay? So in this first module, you have seen with the basics of microwave, all the parameters of transmission line, voltages and current equations, transmission coefficient, reflection coefficient, microwave system construction, and standing wave ratio, its expressions, problems, Smith chart, all these things come under VTU syllabus of module 1. So for module 2, again we have some set of concepts, so that we are going to discuss in the upcoming video. So stay tuned for that. That's all for this video, guys. Like this video, support us, subscribe to our channel and stay updated. That's all, guys. Thank you.